Hello and welcome to Unplugged, an IoT podcast where we dive deep into the fascinating world of industrial Internet of Things and automation. I'm your host, Phil Seboa.
G'day, Phil, and hi, everyone. My name is Ed Fuentes. Well, Phil, you know what? I'm quite excited about today's podcast because one thing I've realized that I suppose over obviously I'm a bit older than you, Phil, and I've seen the journey of communications, especially in the OT space, that this journey of data moving into Ethernet. And Ethernet being that tricky one because it's not deterministic per se, but working out how we get the data in a timely manner, in a timely time, at the right people is very important. And what's important is to talk to people who've done that, who understand the nuances around the effort of what Ethernet has brought to Industry 4.0, as you and I, we totally agree on, well, how important that is to IIoT. And today I'm very excited because Melvin Francis, he's a research-driven engineer. He's specializing in this type of understanding. He's worked with embedded products. He's worked with different businesses to understand the issues and the complexities that Ethernet brings and how that helps us, especially when it comes to IoT. So I'm very excited to talk about real-time industrial automation and real-time communications in this space. So thank you very much, Melvin, for joining us today. We're quite excited.
Yep, the pleasure is mine. Thank you so much for hosting me in your podcast. So I've been following Phil for a long time, and it was a great news when he reached out to my LinkedIn post, and I know uh, I know I'm going to be featured here, and it is so exciting, and also um, we have a great
Perfect.
set prepared for today, and
Excellent.
I'm looking
Absolutely.
forward to it.
Melvin, you've been, exploring the world of industrial automation and sharing your knowledge over, OPCUA, TSN, Industry 4 solutions for a long time now. We'd love to dive deep into, for people that haven't come across you on the LinkedIn sphere, um, maybe you can give us a bit of a rundown on your career journey and some of those key steps within that stage.
Yeah, sure. So let me start with a quick background. So my name is Melvin Francis, and I'm originally from India. So I did my bachelor's in the state called Tamil Nadu, which is the southern tip of India. And after that, I got to do an internship opportunity with a very small company based out of India, and it was back in 2014. And then I got converted, and that's when I got an essence of industrial automation. And from then, it was always industrial Ethernet and deterministic communication was my thing. So I started with a protocol called Open Power Link, which is an open source real-time Ethernet protocol. I was a developer in open source field. I was maintaining it for 4 years, and after that, I had to make a switch to OPC TSN because PowerLink was slowly ramping down its development, and then they want to move to a futuristic technology which is open. And OPCA itself has a huge history. I think even before I was born, it was there in different form. And the reason why I moved was OPCA itself was not real time. So adding a publisher subscriber model and also adding the concept of TSN, which is time sensitive networks, makes it OPCA a real time protocol as well, which we will deep dive in the future. So in this podcast, and what I so this was in 2018, and there were not many developers who knew both OPCA and TSN together. So if you remember, I said I did my internship in 2014, and by luck, I did a project in TSN back then, which was not even named as TSN during that time. So it was luck that I was one of the very few engineers in the world who had this know-how of both OPCA and TSN, and I started with my initial integrations, and from then it was always OPCA, and now I am working for the company called BE Services. We are based out of Germany, which is very close to Munich. The place is called Kempten. We are living in the Alps, so very, very close to the Alps. It's known for skiing, paragliding, all kinds of adventure sports. Yeah, so it's a very nice town, and we are a team size of 15 people, and I'm taking care of technical marketing for all the products and services that we do at BE Services. So that's my short story where I started from India, went around the world working for different teams, different companies. And when I got this chance to move permanently, now I'm with my family here in Germany and doing the work that
That's
I
great.
explained
I
now.
mean, Melvin, I mean, the work you do definitely affects the globe. So the benefit you have is, doesn't matter where you live, the problems we have are global problems. And I love the fact that you talk about real time and time sensitive or time sensitive networks, because as we grow, especially around IIoT and AI, it's important to have that real time data available at the right time, in the right context, at the right space. And we know that AI has been definitely a game changer in industry today. Can you walk us through how that edge AI, how that's revolutionizing the IoT, how that works, and what advantages it brings specifically around the traditional cloud-based models? How is it working, and what are the issues we find?
Yeah. So uh, there's a huge uh, uh, like we need to when we come into industrial automation, we need to have a totally different kind of a mindset. So IoT and IIoT is just industrial is the one word that adds extra, but there is a huge uh, mental change that we need to have when we are dealing with this kind of industrial automation stuff. So if you make a mistake in IoT, what is going to happen if the data is not going to get delivered on time? Your Alexa is going to switch on the bulb few seconds later.
Yeah,
But what happens in
yeah.
industrial automation is people are going to die. There's going to be huge catastrophes that are going to happen. So that when the data has to be delivered, it should be delivered on time. It can be slow, but if I say that, so people really confused between real time and speed. So it's not the data going fast, but the data going on time. So if I say it has to reach in at 12 o'clock, it should be 12 o'clock on time with plus or minus 10 microseconds of jitter. So it should not be anything beyond that, then there is a catastrophe happening. So this is what we say hard real time systems. So to connect with the audience, um, a very, very simple example that I use always is the airbag example. So in your car, when you're driving, if you're using the infotainment play button or if you're opening the window, the delay can be there. Even if it is like few seconds delayed, you just get annoyed. No, there's no problem. But just imagine if your airbag gets delayed. That's where the real problem happens, right? So this is called hard real-time systems. And that is where I've been always working on RTOS systems, Linux, real-time patches, and all the systems that we deliver at BE Services are going to create a huge impact if we do things wrong. So that is what is helping us be motivated, and we wake up daily, and whatever the work that we do, even if it is going to be very, very small, we contribute to a huge greater cause
And, you
is
know, you
what is
mentioned that in
driving us through.
2014 you started this journey. We're 2025 now. How important is real-time data now compared to what 11 years ago was?
Yeah. So, for example, right now, things that we did not have in 2014 is available now. For example, driverless cars. And also in logistics, you have robots that are wireless and they are able to move. And the production systems, which, for example, we had customers who used to have increased their efficiency by 200%. So the same egg sorting machines, which were sorting eggs at a particular X capacity, now it is X into 2. It is multiplying and the production value needs to be increased. And the most important thing that I'm able to see now is the same company who we consulted in 2017. During that time, when we said that you can optimize your system so much using AI and using real time, and they were having a lot of concerns with respect to security, sharing their data, seeing that, okay, so now I need to pay you X amount, but I can use it to hire more people to do these automation tasks by themselves because that is cheaper for them. Now, fast forward in 2025, now the problem is human resources is a huge problem. You do not get cheap labor, or the labor who are also doing the work, they are not having good quality. So now they want to have the same things that we suggested them in 2017. But there is one big problem is, as the technology develops and also the negative side also develops equally, the threat attacks, the security problems, all these are a huge concern for the industrial automation in the industrial automation world. So people are always hesitant to push their data to the cloud, and if the AI happens at the cloud, they are always hesitant. So that's where AI at the edge comes in as a concept, and people want to have their AI models running at the edge. Decision needs to be available in their factory floor, and they want to be as secure as possible, even though there are many other protocols which you can use it to push to the cloud safely and bring them back down. But still, this paradigm change is the shift. We are able to see it evidently, and this is going to change. We'll be seeing more and more in the upcoming years.
What you said was very interesting because what we find, especially around the OT networks, is getting that real time data into the cloud environments to accept it, especially around AI models and that benefit that OT get. But there's this divide with the IT industry. Not that there's this some disharmony, that there is this challenge, and Phil and I have seen this with OT IT industry networking issues. So what are the obstacles that you've counted, that you've seen, and how can we help organizations effectively overcome these challenges?
Yeah, sure. So, when we say IT and OT integration, so I am coming from a field where we discussed about I'm a real time guy who works the real time protocols. So, I would say OT and IT integration, I would put it this way. So, we can always talk about a lot of things like how we can take the data from the factory floor or from the sensor to the cloud. We can have MQTT, we can have OPCA, you can have AMQP, unified namespace. There are like numerous ways where you can push the data from the factory floor to the cloud. But the ultimate thing is, when you want the real time data or the robot control data, that is really, really critical to be sent out. So, this is where you will have both the IT network and the OT network coming into together. So, this is where the security becomes a concern. And also, your real time data should not be interrupted by the OT data should not be interrupted by your IT data. For example, the same example that I want to fall back. When you are in driving a car, your infotainment system can wait, but not your airbag data, which is a catastrophe. So I want to quickly share my slide to show you in a factory network, you could see there are 8 types of traffic classes, which comes like, first of all, the most important one is the isochronous data, which is the robot motor control data. And then you have cyclic data, you have configuration data, then you have the CCTV footage, you have voice over IP. Example, in a huge oil plant, you will have these IP poles that you need to communicate. So all of them are now separated as IT and OT networks, and you need to have Wi-Fi. There are like, you can separate these traffic into 8 different traffic classes. So when they are all in the same wire, you could see on the screen, this is how they are all going to be mixed up, and you can see a Gaussian distribution, and there is no differentiation between what is what, and they are all going to share put on the same time. And the bandwidth, although the bandwidth is available, there is a huge chaos here. So when you bring in the component of TSN, time sensitive networks, so what happens is you're having all the devices time synchronized in a level of nanoseconds, plus or minus 10 nanoseconds. You can go up to sub microsecond nanoseconds. So imagine your watch, Phil's watch, and Ed's watch, like all of them are in nanosecond precision. We can think of a numerous amount of applications. So when this happens, we can all decide and say, this is where you talk, this is where Ed talks, and this is where Phil talks, and everybody gets a bandwidth split. And you can see from the screen, now you can see IEEE 802.1 QBV is switched off. The moment you switch it on, you could see that the traffics are clearly split. So the 8 type of traffic classes, each one gets their own bandwidth in a 1 Gbps. So 1 Gbps is a huge gigabit Ethernet network, and you have the bandwidth. And when you are prioritizing each each frame that is needed, you can see that how clear it is, and there is no worry of dropping. So this is a generic example where I took 8 type of traffic classes and then I'm giving them the equal bandwidth. Now imagine in a scenario like the airbag data always gets a huge place, and then you give some for infotainment and for the other things like maybe your car window, maybe your wiper, or your brakes. Oh yeah, brakes is important, but your brakes might take lesser priority. So depending upon the priority levels, you can split your traffic like this. So this is where all the networks are coexisting, and this is the base layer or the backbone of industrial automation, uh, which gives you the possibility of IT and OT integration.
What does latency look like in this
Yeah.
environment?
So here in this system, when we say when you once we introduce TSN, we have on the latency. So that I can split into two things now. So the jitter part. So when I'm going to send a package. So for example, I can show you an example of a robot application that we have done here. So every time the PLC that is here, the automation PC here has to send its data to the robot that you're seeing here. And the robot calculations are done at the PLC that is available that you're seeing here. So every time the data has to reach, for example, now the cycle time is 1 millisecond. It should be 1 millisecond plus 10 microseconds or 1 millisecond minus 10 microseconds. And anything beyond that, the robot will start to jerk. You can see these jerks happening in the robot. So even if one packet drop happens, then this is done. So the latency that we are seeing is at 1 millisecond cycle time. We can also call this as a round trip time. Every time the the PLC sends the data to the robot gets the numerical calculations, and then it traces a path, and then it should send back the feedback data immediately in the next cycle without any delay. So the latency is just twice the cycle time. So if I'm going to send data for every 1 millisecond, TSN is capable to do this even at 100 microseconds of cycle time. So imagine 100 microseconds is like millions of packets being sent in a minute. That's what we are seeing here, and that's the accuracy that you are able to see. So this robot will give you. So this robot has multiple motors. So one axis, one, two, three, four, five, six axes that you're seeing. So to go in a deeper level, so this particular PLC again sends the position data to two motors that you're seeing here. So you can see these motors are tracing the path with a high accuracy. From the Linux controller, it goes to two different devices, which you're seeing that they are able to track the movements here. So this is what is happening inside that robot axis to give
Yeah,
you
so this
in
is
detail.
why that's so important, right? This is why we need these high-speed networks, especially around that motion control type scenario, right? So that we don't get, wear and tear on our different axes in our motors. They're not fighting each other for control as well.
And there's no polling here, Phil. There's no polling. This is done in the protocol. This is quite an advancement as far as close you can to real time with allocating, like you mentioned before there, the time sensitive networks, allocating the frequency band for the communications to occur over.
Yeah, that's true. So here, from the previous example that I told, this is a TSN switch that you're able to see here. And even if you connect, for example, Phil is the rogue guy in the network, and he comes and he takes his huge video traffic, and then if he wants to plug into one of these TSN ports, it will not affect this entire network, because already we have planned that OPCA publisher subscriber traffic with the priority number 3 has to be cannot be delayed by or interrupted by any other traffic. So even by mistake or by security breach, or if there is a huge gust of an attack that comes in with lot of dummy packets, or uh, huge traffic from CCTV footage or voice over IP, it will not disturb this traffic at any point of time. So the real time is always promised, and this also helps us both the IT network and OT network to coexist. So this gives a possibility of numerous business use cases, which is promised by the Industry 4.0 solutions. So there can be a lot of things happening, and unless and until you have a network backbone underneath, this becomes almost impossible.
What is that network backbone that's required, Melvin?
So for TSN is a collection of standards. It has IEEE 802.1 AS, which is time synchronization, QBV, which is frame scheduling of the frames, and then you have frame preemption, you have redundancy. So all these are collection, and you need to have your Ethernet switches and also your Ethernet layer 1 and layer 2 should support TSN. So this is the backbone that is needed.
So, I guess, at this layer, we're looking at, multiple different process lines, huge industrial, networking. I guess that bandwidth segmentation is really talking to the scale of the operations, or is it, we're having distributed architectures where we're having a lot of alignment in different subnetworks? Um, how do you see, that bridge then between the plant floor time series network and then the IT sections?
Yeah. So, as I said, TSN is a collection of standards, and it's also the Q standards, and the virtualization of network is possible. So, what we do now is we have this huge bandwidth, and we have multiple virtual networks surviving at the same time. And since we have this TSN having, for example, we can have CCTV traffic in a totally different VLAN, and then you are having it in the virtual network, and it's not even going to see the other packets. It's not disturbed. So this is what is going to give you uh, uh, an edge, and also OPCA itself needs the internet connection and access to the external world. That's the beauty of OPCA. So on the OPCA, when you are talking to machine, it uses PubSub. And also when it wants to talk to the cloud or it wants to talk to the ERP systems, it has client server communication, and it has PubSub over MQTT and PubSub over UDP, PubSub over raw Ethernet. It has different QoS depending on the network requirement. So that is the power of OPCA, where the convergence of IT and OT would be possible, and the new business use cases of AI has come in. So AI can be done only if you have the data made available to these systems, right? So that is where the OPCA comes into picture, and also with so many different transport layers available. So I quickly want to show you an architecture which will clearly explain you and give you an idea about how the IT and OT integration can work. So right now I'm talking for OPCA, but still this would be possible for any other protocol that would also be available with TSN as a backbone in the network. So for example, everybody are very much aware of how we are using OPCA. So everybody would have used OPCA as a client server communication, right? So we know that we just need to initialize three variables, and these three variables can be communicated using client server communication. You can come and read the data, write the data, subscribe to the data, change it, configure it, and do these things. So this is very, very normal. I think people who know OPCA would have done this for sure,
Yeah,
right?
yeah,
Phil, like, have you done
absolutely.
this
So back in the
before?
day when I was doing, I guess Phoenix
Yeah.
Contact PLC
So
Next demos, that was kind of my bread and butter of connecting OPC UA pretty much anything as well. I guess one of the challenges around OPC UA is we, start, developing this or utilizing the standard in the same way as well. So there are some
Mhm.
challenges around, I guess, OPCUA as well, and yeah, I'd be interested to learn a bit more around that.
Yeah, so this is the path that the normal OPCA would do. So when you add PubSub, the part 14 of the specification states that you can use the same data that is available in the address space, you can send it over publisher subscriber model. And this publisher subscriber comes with different types of transport layer protocols. So, for example, PubSub over raw Ethernet can be used to control the different data points inside the robot. So, for example, you can have one master controller laying underneath, and then you can control these three motors that you're seeing in the robot. But the robot needs high-speed communication. So, for this, you need to send data at a cycle time of 250 microseconds, which is an isochronous kind of traffic. So, for this, we can use PubSub over raw Ethernet. And also, these same variables can be also used to, so imagine two robots has to be controlled by one master controller. So there is controller to controller communication happening. So now you can use PubSub over UDP, where you don't need sub millisecond cycle time, but you are sure for needed at millisecond cycle time. So for this, you can use PubSub over UDP. But now, coming to a modern use cases where you want to send your factory floor data to the cloud, normally you would need some translation protocols. You need an edge gateway that gets your data and then uses REST, or you uses different kinds of protocols to push it. But since OPCA comes with different kinds of transport layer protocols, it becomes so easy to push these three variables directly to the cloud application using PubSub over MQTT. And also it promises security on the transport layer, on the user level, and it is completely safe, where you can expose the data to the Azure and also to your Amazon cloud. So this is the power of OPCA, and this is where we say OPCA can be available in all the places that you are able to see. So now we saw some examples of controller to device communication, and then we saw controller to controller communication, where one controller communicates to another controller, and then with PubSub over MQTT, you can send the data that is available in the controller directly to the cloud, and you can see the possibilities uh, are endless here.
Melvin, I understand that. I see the graphics. How do you capture the fact that how is industry at with knowing this? How do you see it? You see a lot of customers. What is the uplift for them that's required for them to do this?
Yeah, so the requirement for them to do this is the modern use cases of Industry 4.0. So, unless and until they can expose their data. So, what I always say is you need three things inside your network for your data. You need to do first, you need to collect your data, you need to monitor the data, and then you need to analyze your data. So, unless and until you have a mechanism to collect and monitor, you cannot do AI, or you cannot do big data, machine learning. It will not be possible. So for this scenario, you need to have these kind of digitalization journey, that you need to have some kind of support that is available. So for example, I also prepared a quick demonstration that I wanted to show. So Coligo Edge AIoT is one of our products from BE Services. So here we use OPCA as the interface protocol, and we collect the data, and then we do AI at the edge. So you can see that the Coligo stack lies here, and then it gets the data from the OT layer, and then we do the analytics at the edge and without pushing to the cloud. So this is where we are able to deliver value to the customers by when okay so when I'm able to do everything now without OPCA. But when you have OPCA or MQTT or these IIoT protocols done, what are the business use cases? Are you can predictive maintenance, anomaly detection, time series forecasting, or batch size number one, supply chain management. So all these Industry 4.0 business use cases need this as the background for
Yeah.
to be done.
It's a very interesting point where you know, we're talking about OPCUA, and usually in traditional systems, that's a very ingrained with the OT area, right? Like, how do you get this to be accepted by the IT space? Because, we're moving this data up. Is MQTT the gateway into IT? There's maybe something more familiar to them?
Yeah, yeah. So what we believe in is there is always a mixed perception that people always compare MQTT versus OPCA. So I would say that's a very, very wrong statement to say, because MQTT is a transport layer protocol and OPCA is application layer protocol. So we can't compare both. So both can work together because they are in the different layers. So OPCA can use MQTT because you can imagine OPCA has a um, so MQTT is a truck, and OPCA is not even the goods that we put in. It's just the methods, like how you need to put in the goods. And if I send some data to you, and Phil knows the method that, okay, this is how I need to unload it so that my life is easier. So MQTT, if you just put in all the data without any rules, if you dump everything in a huge truck, then it becomes so, for example, if you want to find one data, it's like a needle in a haystack story. You cannot find it because I did not follow anything. So I just followed my company's protocol. And then if you decide to unload it in your company's protocol, and there's going to be chaos. And OPCA is the middleman who's going to say, this is how your information modeling needs to be done. This is how you need to pack your data. This is how the data type should be there, so that when Phil unloads it, he can easily use it to build a cool UI, or you can use even a different protocol that is famous in Australia. You can build your own OPCA stack. Nobody's going to stop you to do that. So this is the power of open technologies, and that is the belief system that we have. And personally, I uh, do this a lot of OPCA kind of courses, or I do a lot of guides, because I think this makes our life easier. End of the day, that's the underlying fact that I work for.
We agree, Melvin. Phil and I, we're on that journey. We preach and we advocate to our customers: make data easy to accept, make data easy to access. So, can you tell us, Melvin, some of the anecdotes maybe you've had in your experience, some customers that you've worked with where you've seen them potentially have a mess, let's say it, and by implementing this solution, what have you seen transition? What are you seeing?
Yeah.
What are the
So
success stories you've seen, Melvin?
yeah. Sure. I became pretty excited and to show this, because I prepared a small walkthrough and also a cool story, which would also um, be can be used as a very good use case for doing AI at the edge. And I also want to coin this term as brownfield AI. So brownfield is something that there is already some systems running, and then you add something on top of it without disturbing the current system, is called brownfield. And brownfield automation itself was a famous terminology, but I want to coin this as a brownfield AI use case. And I think we are 30 minutes into the presentation, and I want to quickly do some practical stuff so that it's quite interesting for the viewers as well. So this is our Edge AIoT solution. So I'm doing a bit of marketing also, but believe me, this use case is going to be interesting. And so what we do here is, if you have a OPCA server, our solution can come into your OPCA and start collecting the data. And then we can directly do some monitoring. We can do some cool graphs and stuff with very few clicks. And then we can do the analyze part. And then also we can expose it to the cloud, to AWS, Alibaba, or Azure, depending on your requirement. And it's quite easy. And also we have REST API interfaces to build your own ERP systems. So this is the, in a nutshell, this is our Edge AI solution. And this is how our app looks like. So collect, monitor, expose. So this is a Docker instance that I'm running on my PC now. And to show this demonstration, I have this Node-RED OPCA server. So this is something like a demo server, like a gas tank, an oil gas tank kind of an application. So what I'm going to do now is I'm going to collect the data. So I already made a connection, but this is how the connection would look like. You just need to give in your IP address of your OPCA server, and then you put in your demo server's port number, and then you're already inside your server, and then you can start making a connection, and you go next, and then you give your authentication mode. I'm just doing anonymous now, and boom, you're inside the server now. So once you start, you can browse in, and I'm going to go to the tanks, and then I'm going to monitor the gas tank level and oil tank level. And then if I'm going to add to the list, what happens is Coligo is now starting to subscribe these values one by one. It's going to get these values. So you can see now going back to the dashboard, now we have collected these data. Now I can go and monitor them. So this is what is most important, right? So once you collect the data, you should know what kind of data that you're going to receive. And then I can create a quick dashboard, and I'm going to give line graph, and let's see what kind of data I'm going to receive now. So this monitoring has become like within few clicks, there is zero code. This application is specially created for factory floor engineers. So now the monitoring has happened. So now coming back to the use case. So what happened was we were contacted by a packaging manufacturing company. So packaging machine manufacturer company. They have huge lines which would range from some 50 meters to 75 meters. So the packaging happens in different levels. And then they had a robot that palletizes these packaged goods. So what happens is every time they were packaging, the when the robot packages, they had a problem of empty packages going into the palletizing section. So when the robot lifts up and then it gives you this pallet, out of 16 boxes, there were like 4 boxes or sometimes 2 boxes that are empty, which was causing a lot of problem. And they wanted a mechanism to monitor this and see like where the prop issue happens in the production line. So what we did, we went and took this Coligo, and the robot that you saw previously from the demo. I'll also quickly bring back the robot so that our viewers can get a feel about what's happening. So this particular robot also runs an OPCA server. So what happens is all the motor's torque is being, we started to monitor the torque of all these arms here. So what happens is when the robot tries to pick one pallet and put it here, then the pallet is full. The torque, we continuously monitor the torque, and then we did machine learning, and then this model was stored. So once the empty boxes comes in, the torque of the robot system goes for a toss, and then we found out that there is an anomaly, and then we started to analyze this anomaly. So all this without no code, we just monitored using OPCA. And the problem is this particular mistake does not happen like 10 times a day. It happens once in a week, or once over the weekend, once sometimes in the night or day. It happens randomly. So to find out these instances, only if you study the problems, you can go and fix it somewhere. So our solution was able to give these kind of insights in a very, very quick manner, and this helped them to optimize the process. So this is what, so now that we have collected the data, now I need to go to the analyze, and then I need to create a model. So let me put like a test model here. And then what I'm going to do is I'm going to monitor the oil tank level, and I'm going to start learning at the edge. So right now I'm showing this demonstration on my laptop. So just a second. Yeah, no, the yes. Yeah. So what I can do is I can start learning now. So all this learning does not happen in the cloud, but it happens at the edge in our Coligo hardware that we provide along with our solution. So these are the hardware that we have. It's CEV stands for Coligo Edge boxes. So we have CEV 10, 20, 30, depending upon our customers' requirement. We provide them. So the data and on all the learning happens at the edge. So you can see the learning is happening now, and you can see that it will slowly converge to zero. So once it has learned all the data and it identifies that there is no more new data to be learned, then it goes to zero, and then it automatically switches to the inference mode. It might take some time. So, but for example, you can see that anomaly detection service started. So this is something from my old demonstration, and then you will start getting alerts, and these alerts can be used to do some logics and also to study for further improvements of our solution.
That's pretty cool to get that amount of, I guess, uh, value straight from the connection, right? And it's really quick to get that spun up as well. So what types of alerts would you get from this system?
Yeah. So what we do is, so right now when we are going to, uh, uh, when our customer gets this product, they just get the anomaly scores now. So when the anomaly scores is too big, they get an alert. And it also depends on customers' requirement. For example, if they want to monitor humidity or even a parking lot automation. So imagine this particular Coligo device is put into in Munich airport. So they can see a trend of over a month. They can see that at this point of time there are so many flights and the parking lot is going to be full, because using time series forecasting they can do this. And the parking rate can be varied, and also people can also know the availability of their parking, because the time series forecasting is available. So, like this, there are different kinds of possibilities, and it also depends on the user's imagination. Also, they can decide like how they want. But we have interfaces with OPCA. We send back as an OPCA message. We also send back as MQTT, REST API calls, messages, and also telephone calls, depending on how they want it, who's the service engineer, and what kind of method they want to do this stuff.
You know, what's amazing about this is that, we were so used to having to build data models with historical data and use that as
Yeah.
part of the AI model. But what you're telling me, Melvin, now is that not just alone having that old data, that's some data positive, but now we're using real time information through likes of OPCUA, as you mentioned,
Yeah.
with contextualization right at the edge to deliver value. It sounds like, right? Value. Well, like you
Mhm.
said, what else do you want to solve here?
Yeah.
Right at that edge. So that's quite powerful, I think, because there's so much real time data to be observed, to be
Mhm.
incorporated into the system, and that it learns itself right there on the edge.
Yeah. So this is what I called brownfield AI. So when we gave this solution to this particular company, we did not change even a single line of code. We did not ask the factory floor engineers who wants to find this problem to learn any coding or do any coding. It was just clicks that they did to get this data and to get this inference done. So this is what we feel. AI itself is beautiful. We are seeing every day, we are seeing new models, new progressions happening. But to ask somebody to throw away their existing systems, which have been working perfectly for years, and also which has more shelf life before it's becoming obsolete, at least maybe 20 more years, it can work well. You cannot expect them to throw away and bring back new controllers or PLC systems. So that's why we can see AI has come to our phones very quickly. So the cycle time of phones is in terms of months. For cars, I think for a new product to come in, it's 2 years or 3 years. But for industrial automation, it is more than 15 years before they do a revamp of a technology. So it's almost like a lifetime, right? So it takes a lifetime for a new technology to come in. It is much more worse in the aviation industry. The planes looks the same for the past 50 years. They look the same. They are not, new planes are not designed because there's so much of safety parameters are going to be put in inside. So that's why whenever I go to see the go to the theme parks, I think theme parks is the best example of real time system, right? So we can see all the motors and drives. We can't those systems, when they fail, there is huge catastrophes involved. So that's why it takes so much time for people to even change their chips. So even if the one chip becomes obsolete, they don't want to change their system. They just want to migrate to a newer chip, or they want to find an alternative rather changing their systems. So this is where brownfield AI would be a great topic, and that is more sustainable than asking the entire uh, factory floor to be revamped, which is not quite possible, is what I believe.
You're right. I know Phil in his new role, he's working with customers regularly around this space, and in what I do at the moment, we've had these discussions, Melbourne, many times. And what I find is this: I'm going to say a knowledge gap between what we know and what you know. How do we help the people get to what you know? What's the journey for them?
Yeah. So, what I feel is, whatever this particular industry itself is, although we say a lot of things are open, but to find resources that we talk about now. So that's why I like this podcast. Like podcast is so great because whenever I listen to this, I see people's 10 years, 20 years of experience made into like a 60 minutes, although I hear it just before sleeping. The first 20 minutes is always like quite interesting. I just put it on, jokes apart, but still it gives me like how did they transform from 1990s or in 2000s, how the technology was and how technology is now. And these kind of podcasts really do help a lot of people. And also, to my part, yeah, to contribute, what I do is on my LinkedIn profile, I make sure that whenever I come across some really interesting topics or which I think that is a basic knowledge, like I don't want to share complex technologies that we spoke about, but some basics where people want to start. So if you have something that, so for example, if OPCA is going to be a new topic, so I create these kind of small guides where you can find the data to start learning OPCA from now, which is also free. If you're a student, if you're just starting exploring, you can go through these free courses. And also for professionals who wants to learn it in a proper way, I also give some sources which they need to go pay and get certified. So like this for OPCA, for TSN, for Node-RED, or for brownfield AI. So I write these articles, and what I feel is the DMs that I get. So, it's not like Instagram where it goes for a million views. Hardly what my audience are like, it goes from 2000 to 10,000 impressions. But the amount of DMs that I get is so fascinating that that's what keeps me posting these content, because they say they came, they learned this OPCA course, and then they were able to clear an interview, and then they were able to do their project in a better way. They were searching for a solution, and this part that was provided was able to uh, quicken their development life cycle. So this is something that I'm doing right now, and I think I'm getting positive feedback, and I also would love to collaborate with you guys further. So these are some of the articles that I wrote recently, which is also getting some good views and good feedback. And so this is has become a community now. So they don't see me like a person. So whenever they have seeing something new, and then they give me a task of for me to learn, experiment, and then I'm also giving them some code for them to experiment by themselves. And I think this is a very very small start that I'm doing. And when Phil invited, although I'm also going to get some positives out of it, but I could not say no. I wanted to allocate the time, because somewhere it's going to, although we get very very few views compared to other kinds of podcasts, but this podcast is going to change lives, and we are going to make it better. Maybe after 10 years, when we turn back, we know that this is like an artifact that says to the world that this is how it has been, and as humans we have grown so far. So that's how I see it. It might be a bit of exaggeration, but I'm not at all ashamed to say that this is something great that we
Yeah,
people are
I
doing.
totally agree with you, Melvin. Our knowledge is here to be shared with everyone, right? Our experiences build, these platforms that we can really lift the industry by just sharing those lessons learned, and sharing our experiences. So we really appreciate your time today. Going through some of the aspirations on Edge AI and OPCUA and TSN. It's been an amazing uh, conversation that we could dive into for hours, but we want to keep this. Otherwise, all our listeners may be asleep by now as well. So Yeah, so Melvin, all out to our listeners, please connect with Melvin, follow his journey into automation, and please share some of his articles out there that are really valuable for the industry as well. And we are really looking forward to more opportunities to collaborate with more industry leaders out there as well. So yeah, really thank you for your time today, Melvin.
Yeah, and in a crux, thank you so much, guys. So when I started, when I was preparing some background work to set it up, I was thinking how it is going to go. I could say Ed's experience and with your energy, this is a perfect mix. So I love the way this went through the questions and the insights. Also drove me through. I could say I did not plan anything, but you guys put me back into track whenever I was deviating. And I think this duo is great. And I think I would come back to this podcast if you guys would invite me back maybe in 3 months or maybe in 6 months back in time. I would like to come up with some other interesting topic, and because I had fun. So normally I'm a bit nervous, but I was not at all nervous. I enjoyed this process actually.
No, that's great, Melvin. I think what you bring is that knowledge. And, sometimes we take for granted how important time sensitive networks are, how important real time data is, especially in OT layer. We're seeing so much progression in AI. We're seeing so much discussion around real time information. And I think your knowledge, your experience, and you probably undersell yourself. You've got great knowledge, and we are really appreciated. You've been here with us, that you're telling us your story, and I'm encouraging all our listeners. Please, obviously, connect you with Melvin. He's got some great information, great knowledge, and that's important for us because as an industry, we want to share what we have learned. And so, thank you very much for that, Melvin. And please, to everyone listening, don't forget to subscribe to Unplugged and IoT podcast, because we've got so many episodes to come still, so many industry leaders and innovators just like Melvin waiting to talk to us and waiting to share their knowledge with us. So thank you for tuning in today.